Hello everyone, this is Rohan Kokula. I'll be showing you how to visualize data in Tableau. The data gathering video is already uploaded in the playlist, so if you haven't watched it yet, then please go through it so that you'll get clear understanding. Let's start with part 2, that is visualizing data in Tableau. Firstly, let's check the website's data. The last record was on 15th April 11:15 pm. The count on 15th April is 881, so it's updated in our data frame. Let's open Tableau software. On the left side, you'll be seeing the types of files you can import into Tableau. The CSVs can be imported from the text file option. So let's locate COVID-19, and first we'll be using the total cases CSV. If you remember, total cases CSV consists of the daily count and the cumulative count of the respective date of confirmed, deceased and recovered cases. If you'll see, on 15th April, the daily count recorded as 881 on the website and the data is updated over here. The data is divided into two types in Tableau: dimensions and measures. Dimensions include the non-aggregated data and measures include the data which can be aggregated or can be used for mathematical operations. Here on the right side there is a show me button which includes all the visualization types depending on the dimension and measures condition. We'll be using line chart visualization for our data. Let's add the date field into the columns. Tableau automatically detects the data type and converts it into the categories. So the default category is year. You can select the category you want, that is quarter, month, day. The day type will merge all the dates we have in our date field. We don't want this. Let's change the day type to the day of date. This gives all the available dates in our data in that order. Let's drag the confirm field from the measures into the rows. By default, this detects and gives the line graph as the output. Here you can see the daily increase and decrease of the graph. This gives information that on which date there was the highest increase in the daily count. This daily count graph is already there in the website. Let's scroll down and observe it more closely. Select all the states and go to daily count. This shows the exact same graph we have generated in our Tableau software. Let's change the rows from confirmed to cumulative confirmed. Let's remove it and add the cumulative confirmed to the rows. This gives the exponential growth of the confirmed cases. This was the reason to create the cumulated columns so that we can check the growth of cases. To forecast this data, right click, forecast and show forecast. It automatically shows the prediction for the next 10 days. The dark blue line shows the actual values, whereas the light blue line shows the predicted or estimated values. By default, Tableau ignores the last date so that it can be included in the prediction for the cross-checking. On 15th, the actual is 12,370 cases, whereas the prediction gives 12,351 cases. On 19th April, it shows 16,000 as the increase. Let's go to forecasting options. Here, we can specify number of last dates we want to ignore. Here's the forecasting length. It automatically predicts next 11 days. If we want the exact dates of prediction, we can specify here. The maximum number of days Tableau accepts is 100 days. The prediction range is shown here. Let's keep this increasing till 19 days so that we can match it up to 3rd May, that is the extended lockdown period. Prediction intervals gives the range of upper and lower bounds of the predicted line. Tableau has a feature of dual axis, that is, we can show two measures on the same axis, deceased and confirmed. By default, it shows two individual graphs. If you want to combine both into one, then select dual axis. The problem here is, on both the y-axis, the range is different. If we want both the axes to show the same range, then select the desired axis and synchronize axis. This makes it easy to understand both the line graphs lying on the same y-axis plane. If you'll observe the deceased graph, on 15th April it shows 432 as the estimated value, whereas in our website it is 422 as actual value. The deceased predictions shows that by the end of 3rd May, the number of death cases will be around 1k. Let's remove the cumulative deceased field from the rows. If you'll right click on the row field, then it shows the forecast result. This is the actual and forecast both in the same graph. If we want the upper prediction level, then it shows the different graph. Let's merge both these graphs into the same and compare. Let's select dual axis. Here the y-axis is automatically synchronized. The green line shows the upper prediction level, that is, till what extent the curve can grow. On 3rd May, the upper prediction level shows that the total confirmed cases would rise up to 38,900. So this is subjective as the previous records can change and it will change the prediction levels curves as well. Let's select the lower prediction interval. Here the axis doesn't match, so we have to synchronize it explicitly. This curve shows the lower predicted values by 3rd May. On 3rd May it shows 22,681 as the total number of confirmed cases. Let's remove the lower prediction intervals from the rows and add daily confirmed measure. The prediction curve of daily count is linear. Let's synchronize axis. So here comes the interesting part. The prediction line shows that how much could be the confirmed cases per day. This estimation shows that as soon as May starts, the daily count will rise up to 2000. Considering the situation happened at Bandra station, there could be a possible rise in the coming week. Let's open a new sheet and drag the date dimension into the column. Now let's change the date type to week number. This divides our dates into the number of weeks. By this, we can answer to the questions like which week has the maximum affected cases. We'll be using histogram to show this data. Let's drag the week number to the columns. This will automatically create a bar chart. Here comes the interesting part. That is, from 8th March till 14th March, 81 cases were recorded. Similarly to 53, 695 for the respective weeks. If you'll observe, there is a sudden increase in the week 4, 5 and 6. This is probably because of the Tablighi Jamaat movement. This week recorded almost 4,800 cases, which is the highest yet. Let's change the date type from week to day. This gives the chart of daily increase and decrease cases. Let's create a new Tableau book and import the flattening CSV. If you remember, the flattening CSV consists of 3 columns, case 1, case 2 and case 3 based on the confirmed cases values. These were the predicted cumulative values based on confirmed cases. Let me give you a recap of what these cases mean. Case 1 means vaccination period or no new cases from 23rd April. Case 2 means there's a slight decrease in cases from 23rd April. Case 3 means this curve is never bending and is gradually increasing. Let's create a new sheet, add date to the columns and change the date type to the day of date. Now let's drag the case 1 to rows. Now let's observe this graph carefully. This graph grows exponentially till 22nd April. From 22nd April, we have considered an hypothetical situation that vaccination starts from 22nd April and no new cases are found. This will make the daily count as 0 and decrease the curve or flatten the curve. Forecast will give non-exponential line, which is obvious. Let's show the data points on the curve. Let's select line ends option so that it doesn't look messy. Let's create a new sheet for case 2. Drag date dimension to the columns and select day of date. Then we'll drag case 2 to the rows. If we'll observe our data frame values of case 2 from 23rd April, it shows a slight cumulative increase. Let's forecast this data. We'll add 3 points and we'll always show them on the graph. 30th April, 23rd April and 15th April. If you'll observe, the curve is slightly bent from 23rd to 30th April. Let's add case 2 measure again to the rows so that we can calculate the lower prediction interval. Let's change this to dual axis and also change the forecast result to lower prediction interval. Synchronize the y-axis. Here comes the interesting part. We'll be following the reverse process of forecasting. That is, we'll increase the number of days until we'll get a flattened curve. This is a great insight because it gives the estimated number of days to flatten the curve. Now let's keep on increasing the number of days so that the lower prediction curve gets flat. So we have made the lower prediction curve as flat, but this curve is for the prediction intervals as 99%. Let's change it to 90% as default. This curve tells that by 30th May, the curve will get flattened, but this is only possible when the lockdown period gets extended from 3rd May till a week or two. The lower limit shows that the number of cases would be around 46,000 by end of May. This is the crucial part of the curve. Higher the curve, more will be the number of cases, so is the extension to the lockdown. Let's add date to the columns and select date type as day of date and drag case 3 to the rows. This gives an exponentially increasing graph. That is, spread of coronavirus in India doesn't stop. If this is the case, then we'll consider the upper limit for the prediction intervals. Due to this exponential nature, it shows that by May 10, the number of cases would rise up to 50,000. Let's see how more worse it could get by comparing it with the upper prediction interval. So let's drag the case 3 measure to the rows and change the forecast results to upper prediction interval. The upper prediction interval shows that on 10th May, the number of cases could rise up to 55,000. Let's mark the label on 30th April and 23rd April so that we can figure out how the curve is increased. Let's forecast this curve and check what could be the results. We'll now select exactly 1 month as the forecasting period. So by May end, the average prediction shows as 1,12,514 cases and the upper prediction interval shows as 1,12,000. Let's mark the 3rd May label and annotate it to lockdown till 3rd May. Let's do this same for 29th May. Let's change the forecasting duration for exactly 2 months. Let's change the point to last date of the curve, that is on 29th June. This shows the number of cases as 2,11,000. So now you know how much serious it could get. Only doctors can find a way to this problem. But there are some people who are throwing stones on them. These stones will turn into boomerang if they'll get affected with coronavirus. Thanks for watching. If you have any questions, then please mention in comments. Like the video if you found this informative. Subscribe and hit the bell icon so that you'll be notified about my videos. Share this video as much as you can so that more people will get to know about this.